Hello, this is my QGIS Road to Nirvana video, which is entitled Leverage the Power of Open Source Software, Use of NDWI to Map Surface Water. This video is being represented to you by Brighton G. Lakama. So let's look on the agenda of this video. This video is going to look on the uses of surface water. We are also going to cover what is normalized difference water index, NDWI. We are also going to look on the different ways that we are going to use as far as calculating normalized difference water index is concerned. So we are going to look on the workflow, the steps that we are going to take in order to come up with different surface water. And finally, I am going to show you a step-by-step calculation of NDWI, and by so doing, we are also going to look on how we can use this index to map surface water with QGIS. So without wasting much of your time, let's get into it. Surface water is water that is located on top of the Earth's surface and may also be referred to as blue water. So as far as surface water is concerned, what are the different uses of surface water that we have on Earth? First, we have irrigation. Most of the water on Earth or on the surface is being used for irrigation purposes. And secondly, we have industry. Surface water is being used to cool different machineries on industry. And thirdly, we have the most important thing, that is surface water is being used for domestic use on cities and residency. So we can see now how surface water is an important resource, and we can also see how it is important to monitor surface water either time to time or at a certain given time period. We need to ensure that surface water is kept as an important resource and is protected. So let's look on what we call NDWI. What is it that we call normalized difference water index? The NDWI is used to monitor changes related to water content in water bodies. So as water bodies are strongly absorb light invisible to infrared electromagnetic spectrum, so NDWI makes use of green and near-infrared bands to highlight water bodies. In other words, they make sure that all the water bodies have high reflectance compared to other features. NDWI is sensitive to build-up length and can result in overestimation of water bodies. Therefore, that's a red flag that you need to consider whenever you are trying to use this index. So the index was proposed in 1996 by a man called Mark Feeders. You might now wondering, how do we calculate NDWI? NDWI is calculated by a simple formula, per se a ratio. So it's a ratio of green minus near-infrared divided by green plus near-infrared. Near-infrared wavelength is between the range of 0.96 to 0.90 micrometers. And green band is a part of the range where wavelength ranges from 0.53 to 0.59 micrometers. So how do we describe or how do we interpret the result that we get from calculating NDWI? The index values greater than 0.5 usually correspond to water bodies, and those that correspond to vegetation usually have much smaller values, and built-up areas have values between 0 and 0.2. Therefore, we can now use the Boolean formula to calculate or to delineate water bodies and exclude other areas. So we are going to look on that in this video. So let's look on the different workflows that we are going to take throughout this practical or this video. So on the first step, we are going to look on the data. The data that we are going to use is Landsat mode spectral imagery, and we are also going to use the boundary shapefile to delineate our area of interest, because we are not going to use the whole image, but rather we are going to use a small image. And the image that we are going to use for the purposes of this video is the 2018 imagery. We are going to make sure that we use a free and open source software that is QGIS. And finally, we are going to use this as a software, and maybe we are going to use Python, but generally we are going to use QGIS throughout this. The second step that we are going to take is pre-processing the image, but because of the time limit of this video, I have clipped the image before recording. So I am going to share with you maybe some links, if possible, or other videos that I will record as far as clipping or batch clipping is concerned, either using PyQGIS or using batch processing. We are also going to look on how we can now use the QGIS raster calculator to calculate NDWI. On the step number 4, we are going to use the Boolean formula to extract surface water, and then we are going to come up with the result, or a map that shows the water bodies in the selected ones. So without wasting much of the time, let's get into these steps one by one. So like I said, we are going to use QGIS. So make sure that you have downloaded your QGIS and your QGIS is installed. So for me, I have already opened the QGIS project entitled NDWI. As I said already, I have clipped the bands that I'm going to use for this image, for this project. So I am going to use band 3, which represent the green band, and I'm also going to use band 5, which is going to represent the near infrared band. So let's now get started on how we can calculate NDWI. So because from what I said before, we have already covered the first step, accessing the mode spectral imagery, and the second step of clipping by mask. So right now, let's look on how we can use raster calculator to calculate NDWI. So this is how we do it. We come here, raster, on the menu, and we click on raster calculator. So here we have our window showing the raster calculator. So let's get started. So like I said on the previous presentation, NDWI is calculated as green band minus near infrared band divided by near infrared band, green band plus near infrared band. So like I said, the green band is the band 3, and we are going to take this. So first of all, we need to open the bracket so that we don't have any problems. So we are saying the clipped green band, so we double click that, it should come down here. So we are saying green band minus near infrared band, which is clipped band 5. So here we have this. So let's close the bracket and put a division sign, right? And we open a bracket where we are saying green band, we double click that, plus near infrared band, we then double click that, we close the bracket. So we can either select create on the fly raster instead of writing it to the disk. So we can either do that, but for the meantime we want to write it to the disk. So let's save it to the directory that we have. So I have created a directory entitled QGIS Road to Nirvana, and here I'm going to save my output. So I would say NDWI calc and click save. Right now I can see that here down there, if I hover here, the expression is valid. So I'm done. Let me click OK. So what happened now, we have managed to calculate our NDWI index, NDW index. So let's see what are the results. Here we can see, wow. So let me try to zoom this to layer so that we can actually see. So this is the result that we got. So let's now look on how we can extract different water bodies. And as you can see from this video, it's black and white, and water bodies are enhanced in white color, and all those that are non-water are in dark colors. So let's now see what we have now as our result. So our values are like this. Let's go to the symbology of this. So as we can see, we have the maximum value of 0.2 and the minimum value of 0.3. So let's see how we can then view this. So we are going to use random colors to try to classify this. So I was trying to use the unique paletted, but it's gonna be a bit difficult. So let's use the single pseudo and classify. Okay, it's taking some time. So we are going to use the blues, right? So as you can see right now, we have this output from the blue ramp that we have collected. So as we can see now, those values that are higher, those higher values are water, and those lower values are non-water. So what we want to do is to create a Boolean formula that we are going to use as far as extracting water bodies is concerned. So please note that the images that we used were not converted to reflectance, so that's why we are having these very low or weird values. So as far as this is concerned, we are going to use the 0.2. So we are going to say from 0.8 and above is water, and anything that is below this value, this range, is non-water. So we are going to use the Boolean. So the Boolean formula is not very difficult, it's very simple. We are also going to use raster calculator to calculate this. So let's say any value, we want like any value that is greater than 0.8, 0.08 is water, and anything below 0.08 is non-water. So this is what we are going to do. So let's come here to our raster calculator and see what will happen. Right, I don't know what is happening with this. Right, so here we go. This is our raster calculator. So we need to take NDWI calculated. Right, so we are going to use we are going to open the bracket, then NDWI calculated. So we are saying anything greater than 0.8 is water. So we are giving it a Boolean logic, NDWI calculated greater than 0.8 and 0.08, and then we close the bracket, and then we say water surfaces. We want to see what will happen. So let's save this to the directory. So we say water surfaces. Right, so let's try to run this and see what will be the output. Right, so now you can see that we have our output. Wow. So what do we see now? We see a 0 and 1's output. Like guys, this is wow. So we can now see, so you can now see that this data is for 2018, and if we can also download other images for other years, we can now monitor the changes, or we can even monitor the quality of water, whether there is development of water hyacinths inside our surface water bodies. So this is very important. I think this is a wonderful index. So this is the output that we got, guys, and we can see that the coverage of the water bodies that we have. So it's possible now maybe to convert these different water bodies to vector, and then we can now calculate maybe what is the area covered by surface water. And we can also and how we can do that is by going to raster, and then we go to conversion. Then we can either polygonize raster to vector layer, and then from there we have our vector parcels that are categorized as zeros and ones, and the ones that we are saying is like this is what, and anything that is zero is non-water. So we can now therefore calculate area covered by surface water in this district. So for your own information, this area covers Tokwe Mukos Dam in Masvingo, and this area that is wide is the Tokwe Mukosi Dam. So we have managed to extract different water bodies in these districts. So let's just make an output map for this. So how are we going to do that? We are going to use this tool called new print layout. So let me open it, and I will name it NDWI map, right? Or water surfaces. Let me say water surfaces, because now we have extracted our water surfaces. So I will click OK, and here we go. So we have our output, like our print layout. So having our print layout here, let's try to compose the map. So how do we do that? Let me compose it. It's taking some time, I don't know why, but this is going to work. So we are going to put the north arrow, we are going to put the key, we are going to put the scale, we are also going to put the title. So guys, I don't know why it's taking this long, but I'm sure it will be done soon. So I hope it's done now. Right? Okay, let me redo it and see what will happen. Right, so wonderful, we have our map rendered here. So we want to put the basics, like the basic output. I think I am just impressed by this, and then let me say we want to put, first of all, we want to put the key, and then here we have our key. So there are things that we want to remove here, and there are things that we really want. So first of all, we don't want these, so I will click shift, and then first of all I need to deselect auto update, and then I will remove this. Right, so these things like are the things that we don't really want to be shown on our key. We only want those that are important to us. So this is what we want. NDWI calculated, we don't want it, but what we want is the boundary. So we are going to rename it to what boundaries, so that we will be very descriptive. So word boundaries, and then we are also going to rename this as surface water. Okay, Control Z. Right, so we are having this like zeros and ones, and then we don't want like this bent. So water surfaces are those that are represented as 1, and those that are represented as 0. So let me do Control Z, and okay, and I will remove the gray. Fine. So we have our key here. So let me say legend, and I am going to put the border or the frame for this. So we now have our legend. Unfortunately, I have Control Z the word boundaries. Yeah, fine. So we now have our output. We need to put the north arrow here. So we have our nice small north arrow on the corner here. So this is what we want, and we also want a scale. By the way, we don't have it now, so I will put it down here. I think I am okay with this one. I don't want it to be too, yeah. So since we have managed to extract, so I would say we need to give some description on what are the water surfaces and what are not water surfaces. So let me come here and add some text, right, to explain this. So I will come here and say text. So here, so I would say I'm not also good at English, but bear with me. So I would say features in white, or represented, or let me say 1 represents water surfaces. So let me start by like description. And then like I would say 1 represents water surfaces. Water surfaces, or let me say surface water. Surface water. Surface water, and this includes, just to be a bit more descriptive, and I would say this includes wetlands and dams. Wetlands, dams and rivers. Right, full stop. Then I would say 2, 0 represents 0 represents I don't know, non-water. Non-water, that is that is vegetation, buildings, and others. So I think we have give a brief description of what our map shows. So let's give this a frame as well. I think inside the frame will make it look nice. So we have our description and we have our north arrow, we have our everything that we need. So we are not going to put any grids or any kind of coordinates outside, but because of time, so we are going to save this. So let's click on export as an image. So it's saying some WMS servers, e.g. map servers, cannot be printed because of the limit. So that's not a problem, and we are going to say surface water, and we want to save this inside our QGIS Road to Nirvana video. Wow. So save and see. So we want to see like how the output will look like. So done, we have our output. So let's try to open it and see how it looks like, and then we will be done for this video. So this is our output. So this is how it looks like. So to me, it's not bad. It's looking a bit better, though it was like made. So this is what we have. I think it tells a story about different water surfaces and how we can use NDWI. So enjoy your day and enjoy learning. Thank you.